So now I want to look at some issues that can occur with comparing floating point numbers. So floating point numbers are great. There's a lot that we can do with scientific computing that we wouldn't be able to do without floating point. But one issue with floating point is that because of how the numbers are stored in memory, some rounding error can occur. So with floating point numbers, they can have rounding error. This occurs because if we think about fractional numbers, we basically have an infinite number of fractional numbers that we could have. But it turns out there's not an infinite number of binary values. So with the floating point, we have an infinite fractional values. So there's an infinite number of fractional values, but there's only a finite number of binary values. So because of this, we can end up with rounding errors. When we're comparing floating point numbers, we need to be careful with this equal operator. And I want to show you an example of some code with this. So we have this program. Let's just look at what this is doing. So we have a double A that's equal to 1.5 and a double B that's equal to 1.5. And then we add a tiny amount to A. So we have A plus equals, and then we have this point 0, 0, 0, 0, 0, 0, 0, 1. And so technically A doesn't equal B. If we do this comparison, it should, A equal to B should be false. Well, I'm going to run this, and it might actually say that it's false, but the problem is it might also say that it's true. So sometimes this, because of rounding error, this could end up being true. So let me run this and see what it does. I'm going to run this, so PR4. So yeah, this is showing that, so both A and B are the same. We can clearly see in the code, I added a value to A, and so it should show that they're not the same. But this code is saying that both A and B are the same.